previous video, I have discussed about what is the power series, what is the center of the power series, what is the radius of convergence of power series, and what is the interval of convergence of the power series. Today I will discuss some example of radius of convergence of power series. What is the radius of convergence of power series? I will discuss by some example, and this example is very important for any competitive exam. First, to evaluate radius of convergence of power series. This part is very important for any competitive exam. In my previous video, I have seen radius of convergence means actually supremum of the set absolute value x such that the series an x to the power n is converges. That means supremum of this set is actually the radius of convergence. Actually, this idea radius of convergence, because this is look like circle in one dimension. Consider this circle, because here I have considered center is 0. If we consider the series an x minus a to the power n, that means here the center of this series is a, but here I have considered the center of the series is 0. If we consider the circle mod x equal to r, then consisting all values of x for which the power series an xn is converges, this is called radius of convergence, where r is the radius of this circle. That means if we consider this circle, then r is radius of this circle, and outside the circle means here the power series not converges. Outside the circle the power series diverges, and inside the circle the power series converges. Okay, since r is the radius of the circle, so this convergence is called radius of convergence. Also, if we consider this picture, here this distance is r, and in the definition supremum value of all mod x for which the series an xn converges. Therefore, since here mod x, here also minus r, in this interval the series converges, and outside here the series diverges. Also, we cannot talk about minus r and r. Let's see one example, in which example I will understand this better way, why we cannot talk about the convergence of capital R and minus r always. One example, the power series n equal to 1 to infinity x to the power n over n. Notice here n equal to 1 over n. For radius of convergence, here I will use the ratio test n plus 1 over an, which is equal to x to the power n plus 1 over n plus 1 times n over x to the power n. This value n over n plus 1 times x. Now apply limit. Limit n tends to infinity, absolute value of n plus 1 over n equal to limit n tends to infinity. Here if we apply the limit n over n plus 1 absolute value of x, and this value is 1. This is equal to mod x times 1. Therefore, actually, this power series is convergence when mod x less than 1. From this expression, this implies x belongs to minus 1 to 1. And this is actually the interval of convergence. In this region, the power series always converges. Now I will say at the end point, means at the point minus 1 and at the point 1, is the power series is convergence or not. When x equal to 1, then the series is n equal to 1 to infinity 1 over n. We all of us know this series is divergent series. And when x equal to minus 1, then the series become n equal to 1 to infinity minus 1 to the power n over n. And we all of us know by Leibniz test, this series is converges. Therefore, actually interval of convergence would be here the closed interval minus 1 and here the open interval plus 1. Therefore, interval of convergence is closed interval minus 1 to open interval 1. But radius of convergence, because radius of convergence is the supremum value in which the series convergence. This is x equal to 1. Means actual idea is inside the open interval, series always converges, and outside the closed interval, series always diverges. But the end point of this open interval does not matter. Is the series converges or diverges? This is the actual idea of radius of convergence, interval of convergence. Another example, find the radius of convergence and interval of convergence. Of the series x plus x square over 2 square plus 2 factorial over 3 to the power q x cube plus 3 factorial over 4 to the power 4 x to the power 4, so on. Obviously, this series is look like n minus 1 factorial over n to the power n times x to the power n. For radius of convergence, to find the radius of convergence, here I will apply the ratio test. By ratio test, limit n goes to infinity, n plus 1 over n. Here n means this. Here I will use whole series n factorial over n plus 1 to the power n plus 1 times n to the power n minus 1 factorial. Here x to the power n plus 1 over x to the power n. Then after calculating, this value would be limit n goes to infinity n to the power n plus 1 over n plus 1 to the power n plus 1 x to the power n. Here absolute value. Then this is limit n goes to infinity 1 over 1 plus 1 over n to the power n plus 1 x to the power n. Here also absolute value. Now limit n tends to infinity 1 over 1 plus 1 over n to the power n. This value is e. Therefore, this value and this value is 1. Therefore, this value would be 1 over e times x to the power n. And we all of us know this is the power series, and this series converges when this value less than 1. That means when this value less than 1, then this series converges. Therefore, that imply x to the power n less than e. And from this expression, this is clear. Here, modulus of x to the power n. This is clear. Radius of convergence would be e, because e is the supremum distance of this circle with center 0. Here radius is e. Now I will see what is the interval of convergence. That means for which value of x the series converges. This is the given series. When x equal to e, the value x equal to e, then the series would be such type, and this series actually for the value of e, this series does not converges. This series goes to infinity. So similarly, for x equal to minus e, so the interval of convergence would be open interval minus e. Okay? Therefore, to find the convergence of power series, endpoint does not matter. In the open interval, always the series convergence, and outside the closed interval, always the series divergence. Example, find the radius of convergence and interval of convergence of this given series. Here the series is represented as minus 1 to the power n over n square to the power x to the, times x to the power n. Consider this whole term as an. Now I will apply here ratio test. Here the ratio test is limit n goes to infinity, absolute value of n plus 1 over n. Then this is limit n goes to infinity minus 1 to the power n plus 1 over n plus 1 whole square. Here an means n square over minus 1 to the power n, and x to the power n plus 1 over x to the power n. This value would be limit n goes to infinity n square over n plus 1 whole square times x. Okay? And as limit n goes to infinity, this value goes to 1. Therefore, this value is mod x. And we all of us know, since this is series, power series converges when this value less than 1. Therefore, to find radius of convergence, this is convergence when this value less than 1. Therefore, radius of convergence of this series is 1, and interval of convergence would be, at first consider minus 1 to 1. Now then I will see is the end point the power series convergence or not. When x equal to 1, then the series become minus 1 to the power n over n square. And we all of us know by Leibniz test, this series always converges. And when x equal to minus 1, then this series reduces 1 over n square. Also, this series, since p equal to 2, this series also converges series. Therefore, here the interval of convergence would be close interval minus 1 to 1. This is the interval of convergence of this series. And in this region, the series is converges, and outside this region the series is diverges. Radius of convergence is supremum of this set. If this set is unbounded, means r equal to infinity, that means radius of convergence is infinity. And when radius of convergence is infinity, then this implies the series convergence for all values of x. Let's see one example also. To find the radius of convergence, here also I will use the ratio test. Consider this whole part is an. Limit n goes to infinity, absolute value of an plus 1 over an, and this is equal to limit n goes to infinity minus 1 to the power n plus 1 x to the power 2n plus 1 over 2 times n plus 1 factorial times here 2n factorial over minus 1 to the power n x to the power 2n. Here after calculating this value would be x square over 2n plus 2 plus 2n plus 1. After putting the limit, this value would be infinity. Sorry, 0, not infinity. And 0 is always less than 1. Therefore, for all values of x, since this value is less than 1, this power series convergence. And since for all values of x, this series converges. Therefore, radius of convergence is infinity. Since for all values of x, the series converges. Therefore, interval of convergence is minus infinity to plus infinity. I hope my all viewers have understood. This set is unbounded. That means radius of convergence is infinity. Now I will see what is the radius of convergence and interval of convergence of this power series. Series n equal to 1 to infinity x minus 3 to the power n over n. Here center of this power series is 3. And an equal to x minus 3 to the power n over an. Here also I will use to find radius of convergence. I will use the ratio test an plus 1 over an, limit n tends to infinity. This is equal to limit n tends to infinity x minus 3 to the power n plus 1 over n plus 1. An means n over x minus 3 to the power n. Okay. This value is absolute value. Limit n goes to infinity x minus 3 times n over n plus 1. And this limiting value is 1. That means this value is 1 times x minus 3. And obviously, this power series converges when this absolute value less than 1. Okay? That means here x lies between 4 to 2. In this region, the power series converges. I will see, is the series convergence at the end point? For this, at first I will check x equal to 4. X equal to 4. Then the series n equal to 1 to infinity 4 minus 3 to the power n over n, and this is equal to actually this series n equal to 1 to infinity 1 over n. and this series is harmonic series. So this series is divergent. Okay, and when x equal to 2, in the series n equal to 1 to infinity 2 minus 3 to the power n over n, this is equal to series n equal to 1 to infinity minus 1 to the power n over n. Obviously this is convergent by Leibniz test. So this series is convergent. Therefore, interval of convergence would be, here would be closed interval, that means close to open 4. In this region, the power series be convergence, and radius of convergence of this series is 1. Now I will see different type of interesting power series, and I will see what is the radius of convergence of this power series. We will see radius of convergence of this power series 2 to the power 2n times x to the power n square. Here also I will use ratio test. Limit n goes to infinity an plus 1 over an, where an means this whole term. Then this would be limit n goes to infinity 2 to the power 2n plus 1, here x to the power n plus 1 whole square, over 2 to the power 2n times x to the power n square. Then this value would be limit n goes to infinity 2 to the power 2n plus 2, here 2 to the power 2n, absolute value, here x to the power n square plus 1 plus 2n, here also x to the power n square. Then cancel this term, then this value would be limit n goes to infinity 4 times x to the power 2n plus 1. And this power series is converges when this part less than 1, here absolute value, that means that imply limit n goes to infinity absolute value of x to the power 2n plus 1 less than 1 over 4, x to the power 2n plus 1. But we have to find for mod x. For this, limit n goes to infinity x to the power 2n plus 1, here divide this part by 1 over 2n plus 1. Similarly, for cancelling, this is divide 1 over 2n plus 1, here mod x. Then this value would be mod x, and after putting the limit, this value would be 1. That means radius of convergence is 1. And what is the interval of convergence? This is open interval minus 1 to 1. Put the value at the end point 1 and minus 1. At this point, this series would be diverges. So, interval of convergence would be open interval minus 1, 1. Now I will say radius of convergence and interval of convergence of this power series. Here also I will use ratio test. Actually today's all example based on ratio test. Here this is an, then limit n goes to infinity, absolute value of n plus 1 over an. After calculating this limit, this value would be limit n goes to infinity, absolute value of x plus 2 over 3 n plus 1 over n. Obviously, if we put the limit, then this value would be 1. That means this value would be absolute value of x plus 2 over 3. And obviously this power series convergence when this less than 1. That imply absolute value of x plus 2 less than 3. Therefore, radius of convergence is 3. Now my question, what is the interval of convergence? Interval of convergence would be minus 5 to 1, that means open interval minus 5 to 1. Now I will check, is this power series convergence at the end point when x equal to minus 5, then this series would be series n equal to 0 to infinity n times minus 3 to the power n over 3 to the power n plus 1. This value would be 1 over 3. Series n equal to 0 to infinity minus 1 to the power n times n. And when n goes to infinity, obviously this value goes to infinity. So this series cannot convergent. This series is divergent series. When x equal to 1, then the series become n equal to 0 to infinity n times t to the power n over t to the power n plus 1, because just put the value when x equal to 1, then this value would be series n equal to 0 to infinity n times n over 3, and obviously this value goes to infinity as n goes to infinity. So this series is divergence by divergent test. Therefore, interval of convergence of this power series is open interval minus 5 to 1. I hope my all viewers have understood power series, how we have to find radius of convergence and interval of convergence of power series. Today I will stop here. In my next video, I will discuss interval of convergence of power series by Cauchy-Hartman test. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.